recurring numbers. Then I ask you a question on how you can convert a recurring number into fraction and then solve, or a fraction is given, what will be the recurring part, few recurring numbers to be added up, and blah blah blah. Any arithmetic function with recurring numbers, and here we will see what different kind of question can be built around recurring numbers. But before that, let me go through what and how to convert them into fractions. So let's begin the magic. So first basic idea about how to convert a recurring number into fraction. If suppose I have 0 dot a and there is recurring on a, this is actually written as a by 9. Quickly I'll go through why. Let x equals to 0 dot a. Recurring means it is just moving till infinity. Now if I multiply this by 10, it will become a dot, again a, again I can write it till infinity. Now if I subtract these two, I'll get 9x equals to, all these decimal part will vanish, a. That means x is equals to a by 9. That is the logic behind how to convert a recurring number into a fraction. I'll take a few examples and I'll give you the direct code now and not the entire thing, that you can yourself find it out. Okay, so what are the different formats? Next format is 0 dot AB, and suppose recurring is on both the digit AB. That means the number is moving like 0 dot AB, 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 AB like this. So if we have recurring on two digits, two continuum digits, obviously, then it is written as AB by 9, 9. We'll take up next example. Next format in recurring number is A dot B recurring. Now we can see that there is one digit which is before decimal point, यानी उसको इंटीग्रल वैल्यू बोलते हैं. अब इन सबको किस तरह से डील करें? या तो आप इनको अलग अलग कर दो. You can call it A plus 0 dot B bar, or you may write this as A plus B by 9. Yes, you can write like this. But if I want to convert this in one shot into one single fraction, I'll ask you to do something like this. Write the entire number without decimal, without recurring, as if it is a two-digit number. Now subtract all the non-recurring digits part. Here in this particular example, A is the non-recurring digit part. I have subtracted A, divided by the number of recurring digits after decimal point. There is only one digit which is recurring after decimal point, divided by that many 9. If you will solve this, you will get this. So quickly let us see one example, and with both the formats, so that this thing clearly goes in our head. 5.4 recurring. If I use this format first, this is 5 plus 4 by 9, which is 9 into 5, 45, plus 4, 49 by 9. Bingo, 2 steps. Now, if I am using format number 2, how I can get this correctly? 5.4 recurring is actually 54 minus 5 by 9, because there is only one recurring after decimal point. 54 minus 5 is 49 by 9. Got it. I hope this is clear with all of us. Good. Now this is not the end of the format. I have one more. Let's see. Another format in recurring number. 0 dot xy bar or recurring only on 1. That means there is one or more than one non-recurring part after decimal now in this case. This is again treated as if there are no decimals no recurring part, just write the number. It is xy. Deduct all non-recurring parts, x. Divide by number of digits recurring after decimal point, 9. Number of digits recurring after decimal point are 1. Therefore, I will write 1 times 9. Now, how many digits are there which are non-recurring and occurring after decimal point? There is only one digit. For that, we need to put a 0. And hence, this will be converted into a fraction. Like for an example, I should write an example too. 0.51 recurring on 1. This can be easily written as 51 minus 5 non-recurring divided by 9 because there is one recurring digit, and I'll put 1 0 because there is one non-recurring digit after decimal. This is very important. After decimal. So this becomes what? 51 minus 5 is 46. 46 by 90. Now I can cancel this by 2, I guess. Yes. So this will be 23 by 45. You can use calculator or you can divide it after viewing this session. Or you can pause the video and check it. Right? 23 by 45 will give you 0.51111111, and that is what is recurring number. One more format from my end so that everything about recurring numbers is crystal clear with us. Let me introduce the last format and I will mix everything up. X dot YZ and recurring only on Z. So, yes, you thought it correct. Treated as if there is no decimal, no recurring, it should be X, Y, Z. Deduct all the non-recurring digits, whether it is after decimal or before decimal. Deduct X, Y. Great. Divided by how many digits are in recurring mode? 1. I'll write 1 9. How many digits are there after decimal point which are not in recurring mode? And we have got one digit. I'll write 1 0. This is the format. Quickly, let me take one example also to make this very clear. Let me take 5.14 recurring on 4. 3 digits, 514 independently written. Deduct non-recurring digits. 51 divided by how many 9s we should be placing? 1 9 because we have one digit on the recurring mode. How many zeros should be there? 1 0 with a 9 because we have one digit non-recurring after this. So finally it boils down to 463 by 90. I hope the conversion of recurring numbers to fractions is clear with us now. Find 8.32 recurring on 2 plus 13.1436 recurring on 3 and 6 plus 0.047301 recurring is on 301, and to this I need to add up 0.2347. This is a terminating number, this is not a recurring number. So there is no recurring, this is ending here, so we call it terminating number. Now I need to find some of this. Now question can be developed on this too, that how many digits would be recurring in a number which is actually equals to this, or they can ask you, is X a recurring number? If X is a recurring number, how many digits are recurring? If X is a recurring number, then which are the digits which are recurring? These kind of questions can be developed, and solution to all these kind of questions is nothing but just we need to find the total. We need to know how to do the addition. We have a simple process. Let's follow it slowly. Concept is the queen and content is the king. First step. Look out for the recurring portion in on all the numbers given. This is a non-recurring number, इस फॉर्म नहीं देखें. Here we have one digit on the recurring position. Here we have two digits in the recurring position. And here we have three digits in the recurring position. We just need to find the LCM of 1, 2 and 3. LCM of 1, 2 and 3 is 6. This means what? There should be 6 digits in a recurring mode in X. How many digits would be in the recurring mode in X? Just you simply find the LCM of number of digits which are recurring in the three recurring numbers given in this expression. Now, what next? We also need to find the maximum number of non-recurring portion. Maximum number of non-recurring portion, let me write that first. We need to find maximum number means here digits. Maximum number of digits of or in non-recurring portion. How to identify that? So that you need to identify the biggest of the non-recurring digits. This is 1. Here we have 2 digits. Here we have 3 digits. And here we have 4 digits. These all are non-recurring because it itself is a non-recurring number. This gives us an entire picture that when X would be written, वो कुछ भी हो सकता है, after decimal point 4 digits would be non-recurring और उसके बाद 6 digits would be recurring. This would be the format of X. मतलब without actually finding the sum, we have calculated these many things. And if question is asked related to only these things, then directly we are in position to answer these. So first is 8.32 recurring on 2. Now, when we have got that this is 4 and this is 6, learn how we are going to write this. Okay. First we'll write this as 8.3222. Why I have written 4 times? Because we have 4 non-recurring portions. उसके बाद we have 6 digit recurring position. I'll write this recurring part 6 times. 5, 6. And then again 2 more times to show you that actually there is no harm in not writing this column also. Zero everywhere for this. Now you just simply add up the way you know to add actually. 6, 7, 8 and 1, 9. Eight, 3, 11 and 2. Now, can you give me the value of X? Yes, X is there in front of you. X is equals to 21.7478 with recurring of 598871. We will write bar on 598871. अब बाद में भी देख सकते हो you are getting 59 again. इसके आगे भी अगर आप recurring digit लिखोगे, you will keep on getting 598871. 598871. I hope this is clear with all, and yes, they can ask us questions based on this. At the end of the video, keep watching. I'll put up few more questions related to recurring, and I hope you will pause the video and solve it out. There is one thing which you need to believe is magic happens. This is Mohit Jain signing off from MJ's Maths and Stats. Thank you.